Mr Cohen here for Maths. So today we're doing a higher mathematics 2025 mock exam paper 2, courtesy of Mr Serra. Hopefully you find this useful. And remember, if you are finding this useful and you want a last minute boost on Sunday, then Sunday will come for me just the night before the exam at 6 p.m. We've got a YouTube members only live stream for higher maths, going through lots of exam prep and tips and tricks for the final boost to get you the best grade you possibly can. Members only, so just click the link to join now. Look for members only tab. Clever Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code CleverMaths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code CleverMaths. The links are in the description and down below. SQA Higher Maths 2025 Paper 2 Mock Exam Question 1. Triangle PQR has vertices P, Q and R, -4, -1, 2, 5 and 10, 1. Find the equation of the altitude, then the median, and then the angle that the side PQ makes with the positive direction of the x-axis. So let's start off with looking at our altitude from Q. We've already got a nice dotted line in, very nice. And it makes a right angle there. So if I find the gradient of PR, then M1 times M2 equals -1 because they're perpendicular. So P is -4, -1. And R is 10, 1. So our gradient of PR is 1 minus -1 over 10 minus -4. That's 2 over 14, which is 1/7. So that means that the gradient of our perpendicular is equal to -7 because it's the negative reciprocal. Flip it upside down, change the sign. And we need to say why, because M1, M2 equals -1. And then now we need a point on that line. So point Q is on the line at right angles, which is 2, 5. And now we can work this out by doing y minus b is mx minus a, y minus 5 equals -7x minus 2, y minus 5 minus 7x plus 14. So y finally is -7x plus 14 plus 5 is 19. And we're done there. Question B says, find the equation of a median from P. So I was cutting this at in half. So I need the midpoint of QR, and that will tell us this, and then I can do the gradient and so on. So I'm going to call that M, midpoint. So Q is 2, 5, and R is 10, 1. So for B, Q is 2, 5, R is 10, 1. So our midpoint M is equal to 2 plus 10 over 2, 5 plus 1 over 2, 12 over 2 is 6, and 6 over 2 is 3. So there's our midpoint, and then using the point P, which is -4, -1. So I've now got P, -4, -1, and M, 6, 3. So our gradient is equal to 3 minus -1 over 6 minus -4. 3 minus -1 is 4 over 10. Simplify that to 2/5. And then use any point you want for your A and B. So I'm going to use my M because the numbers are easy to work with, okay? So there's my A and there's my B. Y minus B, Y minus 3, 2/5, X minus 6. So now when you've got a fraction like this, it's best to take the 5 up to the other side. So you've got 5y minus 3 equals 2x minus 6, 5y minus 15, 2x minus 12. And you really want to leave the y's and the x's on the same side and the number on the other, or make it all equal to 0. So I'm going to put the y's and the x's on the same side. Y minus 2x. Move the 15, so it becomes 15 minus 12 is 3. And I think that will be fine there. If you prefer, you can move it so you get y equals 2/5 of x, and then you would have plus 3 over 5. There's no real need to leave it like that, it's a bit messy. Calculate the angle that the side PQ makes with the positive direction of the x-axis. So we've got PQ, which is here. So remember, gradient equals tan theta. So I want the gradient of P and Q. Have I done that yet at any point? Probably not. Okay, so let's do that. So our P and our Q, I need to actually look them up again, is -4, -1, and 2, 5. So our gradient of PQ is equal to 5 minus -1 over 2 minus -4. That equals 6 over 6, which is 1. Gradient equals tan theta, so that equals 1. So I want the inverse tan of 1. Now that is actually an exact value, it's 45 degrees. But if you didn't know that, no biggie, because you are using a calculator in this question. But just to remind you, if you go 45 here, you get a 1, 1 and a root 2 here. Tan of 45 is 1. So the angle is 45 degrees, and we're done there. Next, we have Maths 2025 Mock Paper 2, Question 2. The vectors u and v are such that the size of u is 3 and u dot u plus v is 9. Determine the size of the angle in between vectors u and v. Now, you might be thinking you're using the formula for this, and you may well be, but let's just actually look at what we've got. If I expand this, I get u dot u plus u dot v equals 9. Now, looking at the start of the exam paper, just to help us remind us of something, it does say that u dot v is, well, you can the components times together and added, but it also says this. Now, if I've got u dot u, that means I've got the size of u times the size of u times the cos of the angle in between. But if you've got a vector in the same vector, there's no angle in between. It's just the cos is 0. So what's the cos of 0? Well, using a graph to help if you really need to, the cos of 0 is 1. So that means that u dot u is just the size of u times the size of u. And I'll leave u dot v alone now to see what I get for u dot v. So u times u is 3 times 3. So that's 9 plus u dot v equals 9. So if I take away 9 for both sides, really, I get u dot v equals, well, 0. Well, what does that tell you? Well, let's have a look at this graph again. If u dot v is the size of u times the size of v times the cos of theta, and assuming that v isn't 0, that means that the cos of theta is, well, 0. So when is that 0? It's when it's at, first of all, 90 degrees. So that means that they're perpendicular. So I can say that since u dot v equals 0, that implies that u and v are perpendicular, and therefore theta, the angle in between, is equal to 90 degrees. And we're done there. Basically, hi, I'm Maths 2025 Mock Paper 2, Question 2. Functions f and g are defined on suitable domains by f of x is 3x and g of x is 2 sine x. Find f of g of 270. There's two ways to do this. You can sub 270 into g and then do the answer to that subbed into f. Or you can find f of g of x. I'll show you both ways just in case. So g of 270 is the easiest way to go. That's 2 sine 270. Again, this is a calculator paper, so you could just put it in your calculator. But 270 is here, which is at -1. So that's 2 times -1, which is -2. So then, subbing that in, that means that f of g of 270 is just f of -2, which is 3 times -2, which is -6. If you didn't want to do it that way because you feel like you need to do f of g of x, just in case, f of g of x means I take f, which is 3x, and I write 3g of x, and g of x is 2 sine x. So that's 3 times 2 sine x, which is 6 sine x. And then you sub in 270. So f of g of 270 would just be 6 sine 270, which is me back to the same. That's -6. 6 times -1. You get the same answer of -6. And we're done there. Right, next question for g of f of x. Part B, we've got g of f of x. So that is, well, what's my g? My g is 2 sine x, so 2 sine f of x. My f of x is 3x, so that's 2 sine 3x, and we're done there. SQA Higher Maths 2025 Mock Paper 2, Question 4. Express 3x squared minus 12x plus 19 in the form ax plus b squared plus c. In other words, completing the square. Given that f of x is equal to this, show that f of x is increasing for all x a member of R. Let's hope that that's got something to do with part A, which probably it does, let's be honest. So, part A. How do we do this? Well, we just leave that 19 hanging out. And I've got my 3, I take that out as a factor of x squared, and then minus 4x. And I just complete the square on the x squared minus 4x part. So that's 3. X minus 2 all squared. Immediately take away 2 squared, so take away 4. And I've still got in plus 19 hanging outside that bracket. I then expand it a bit. 3x minus 2 all squared. 3 times 4 is 12, plus 19. So that gives me 3x minus 2 all squared, finally. 19 minus 12 is 7, so plus 7. And we're done there. Part B says f of x is this, show that it's increasing. So let me just write out that. F of x is x cubed minus 6x squared plus 19x plus minus 4. That's 19. So to show that that's strictly increasing, well, what you can do there then is that you can differentiate that and examine the stationary points and see what happens either side. So let's just try that. So if I do f dash x, well, I get 3x squared, 2 6's is 12x, and then 19. Now that looks similar. That was part A. So that equals 3x minus 2 squared plus 7. So at this point, you can then say, well, x minus 2 squared is always greater than or equal to 0, because when you square something, you always get a number at least 0, if not bigger. And that means that since you've got 3 times a positive number, at least, or 0, plus 7, that means that f dash x is always greater than or equal to 0. And since f dash x is always greater than or equal to 0 for all x, that means that the gradient of the tangent is always positive. And therefore, f of x is strictly increasing for all x. I presume a member of the real numbers, yeah, because it's not necessarily true, but it probably is for other ones. And we're done there. SQA Higher Maths 2025 Mock Paper 2, Question 5. We have got solve 2 cos 2x equals 1 minus 11 cos x. So I can expand cos 2x, and the start exam paper has 3 forms for this, but since the right-hand side has a cos in it, I'll use the one with the cos in it, so it's all cos. So I've got 2. Cos 2x is 2 cos squared x minus 1. And that's equal to 11. 1 minus 11 cos x. We're working in radians here, bear in mind for this question. 4 cos squared x minus 2 equals 1 minus 11 cos x. So that's a quadratic trig thing. Well, trig thing, I mean equation, of course. So 4 cos squared x. Take away minus 11 over to make plus 11 cos x. Minus 2, take away another 1 is minus 3. So that is a bit like just a quadratic. So you can use the quadratic formula, or you can factorize. Most of the time these will factorize, so I would try ahead and factorize it if I were you. So factorizing it, we want factors of 3, which is 3 and 1, and then it's cos x on either side. And then it's either going to be 4 and 1 or 2 and 2. So let me try 4 and 1 first. 4 3s is 12, and then 1's 11. So that's going to work. So I'll just do that then. 4 and 1. And I need to get my signs right now, so I want to make plus 11. So 4 3s is plus 12, minus 1 is 11. and then minus 1 times 3 is minus 3. So that means our first bracket equals 0, or our second bracket equals 0. Solving them separately, you get cos x equals a quarter for the first one, or you get cos x is equal to minus 3. Well, cos x is never minus 3. It's always up to 1 or down to minus 1, so that has no solutions. This one I can do the inverse cos of a quarter. Making sure I'm in radians, shift cos 1 over 4 is 1.318, so I'll just put 1.32, I think. And then I need other solutions between 0 and 2 pi, so it's a cast diagram usually is what we would play with. Cos was positive, so it's 2 pi minus at that point, so our angle x is equal to 1.32, or equals, calculator, 2 pi, literally pi, minus 1.32 is 4.96. And we're done there. SBA Higher Maths 2025, Mock Paper 2, Question 6. As part of an experiment, a bowl of water is placed in a controlled heated container. Due to the heat, 16.8% of the water evaporates from the bowl of the hour. To increase the volume, 50 ml is added at the end. In terms of relationship, this looks like UN is the volume of water in the bowl in millilitres n hours after the experiment started. It's known that UN and UN plus 1 satisfy the recurrence relationship. State the values of A and B. Okay, so let's just keep this on the screen. A equals B equals. So it says 50 ml is added at the end of each hour. So B is obviously 50 then. And it says that UN is the volume of water in the bowl. And due to heat, 16.8% evaporates. So I'm not left with 16.8%. I'm left with 100 minus 16.8%, which is 83.2%, which I can change to a decimal. Just by dividing by 100, 0.832. And there we are for A and B. Part B1 says, explain why a volume in the bowl will stabilise in the long term. Well, we've got UN plus 1, remember, is 0.832 UN plus 50. So we can just say very simply that the limit exists as minus 1 is less than 0.832, which is less than 1, and therefore the volume will stabilise in long term. That's it. Very simple. Part 2. The experiment will stop when the water in the bowl. Part 2. The experiment will stop when the volume of the water in the bowl stabilises. Calculate this volume to the nearest 100 mil. So now let's calculate the limit. So L equals B over 1 minus A, remember. B is 50. 1 minus 0.832. I'm not going to do any more of that without a calculator. 50 divided by bracket 1 minus 0.832 gives me 297.619. I am going to round it. Which equals to the nearest 100 millilitres, 300 millilitres. And we're done there. SQA Higher Maths 2025 Mock Paper 2, Question 7. We have got the graph shown as an equation, x cubed plus 3x squared minus 6x minus 8. The total shaded area is bounded by the curve and the x-axis. Calculate the shaded area above the x-axis, then total shaded area. So above the x-axis is just from here to here. And it's an integral to area. So part A, I want to integrate between minus 4, minus 1, x cubed plus 3x squared, minus 6x minus 8 dx. Okay, integration, add 1 to the power, divide by the new power. So that's x to the 4 over 4, or a quarter if you prefer, plus x cubed, 3 of them, over 3, minus 6x squared over 2, minus 8x minus 4 and minus 1. Simplify as best you can. So that's x to the 4 over 4 plus x cubed minus 3x squared minus 8x. And then sub in, because you get a mark for your substitution. So don't do anything until you're subbed in. So I've got minus 1 to the 4 over 4 plus minus 1 cubed minus 3 minus 1 squares minus 8 minus 1s. That's one thing. Take away, it's always take away now, minus 4 to the 4 over 4 plus minus 4 cubed minus 3 minus 4 squares minus 8 minus 4s. And at this point, this is where a lot of people start making mistakes, but usually it's only worth one extra mark to get the final answer, so don't worry your little head if you find that a little bit difficult, but let's just try it anyway. I'm going to do a lot of it manually because I know that I won't make mistakes manually. Minus 1 to the 4 is 1, so that gives me a quarter. Minus 1 cubed is minus 1. Minus 1 squared is 1 times minus 3 is minus 3. Minus 8 is minus 1 is plus 8. So there's my first bracket a little bit better. Take away my second bracket. Well, I can't do 4 to the 4 in my head. Well, I can actually. It's 196, but let's just do it anyway. No, it's not. It's 256. There we go. See? Don't make mistakes. And it's positive because it's a negative times a negative times a negative times a negative. So it's 256 over 4. 4 fours is 16 times 4 is 64. 4 fours is 16. 16 times 3 is 48. So it's going to be minus 48. And then 8 fours is 32. Bracket, we've got 8 minus 3 is 5, minus 1 is 4, and then an extra quarter. So you've got 4 and a quarter. And then your second bracket, well, we've got 256 over 4, which is 64. 64 minus 64 minus 48 plus 32 is minus 16. So minus minus 16. So that makes 20 and a quarter units squared, or if you prefer it in terms of an exact value, 81 over 4. Part B, hence calculate the total shaded area between minus 1 and 3. So it's between minus 1 and 3, but underneath the axis. So it's 0 minus this, because I'm going underneath basically x equal to 0 here. Part B, hence calculate the shaded area. So I'm going between minus 1 and 3. Underneath the x-axis, which is y equals 0. So I need to do 0 minus the function x cubed, blah, 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 blah. So I'll switch the sign and everything. There's other ways to deal with this, but I think that's the most sound mathematical way to think about it in terms of my head anyway. So I've got minus 1 and 3. I just switch the signs out. So it's minus x cubed minus 3x squared and minus 6x minus 8 becomes plus 6x plus 8. Now I've already integrated that, or at least the one with the signs different, so that's fine. So if I just take that, I get minus x to the 4 over 4 minus x cubed plus 3x squared plus 8x, all between minus 1 and 3. And then we just sub in. Minus 3 to the power of 4 over 4 minus 3 cubed plus 3 squared plus 8 3's. Take away minus 1 to the 4 over 4 minus 1 cubed plus 3 minus 1 squared plus 8 minus 1's. Evaluating that then, we've got 81 over 4 minus 27 plus 27 plus 24, that's our first bracket, minus 1 to the 4 is 1, but then it's a minus in front, so it's minus a quarter. Minus 1 cubed is minus 1, then another minus is plus 1. Minus 1 squared is, well, just 1, so that's plus 3, and then minus 8. So the 27's cancel here, so you get minus 81 over 4 plus 24 is 3.75, or 15 over 4 for the first bracket. And then for the second bracket, minus 1 over 4 plus 1 plus 3 minus 8 is minus 17 over 4. So we've got minus 17 over 4. 17 and 15 is 32 over 4. So happy enough, that's 8. So that means that our total area, because that's just 8 for that bit, and then our first bit was 20 and a quarter. That gives me 28 and a quarter units squared, or if you preferred it as an exact value, like as a fraction, you get 113 over 4. And we're done there. SQA Higher Maths 2025 Mock Paper 2 Question 8. The equation px squared plus 6x plus 2p plus 7 equals 0 has equal roots. Determine the possible values of p. So px squared plus 6x plus 2p plus 7 equal roots means look at the discriminant. So we're saying that b squared minus 4ac equals 0. So a is p, b is 6, and c is 2p plus 7. So we've got 6 squared minus 4 times p times 2p plus 7 equals 0. 36 minus 4p bracket 2p plus 7 is 0. 36 minus 8p squared, 4 7s is 28, minus 28p equals 0. I'll make the p squares positive, move it right. 8p squared plus 28p minus 36 equals 0. Now solving that, I can see there's a common factor straight away of 4. So that gives me 2p squared plus 7p minus 9. So I've got 4. I'll have 2p and p. So let's try factors of 9. 9 and 1. 2 and 9 is 1. 18 and 1 does never make 7. 2 1s is 2. 2 and 9 make 7. So 2 1s is 2 and 9. And I want to make 7 positive. So 9 times p minus 2p. So that means I get 2p plus 9 equals 0. P minus 1 equals 0. So for this one, it's minus 9 over 2, and for this one, it is 1, and we're done there. SQA Higher Maths Mock Paper 2, Question 9. The diagram shows the cubic graph y equals f of x with stationary points at 0, 10. We have to sketch the graph of minus f of half x. So minus in the front means we're reflecting the x-axis, and a half means that it's kind of stretched, I suppose, or truncated. So what does that actually mean? Well, let's reflect it first. So 10 becomes minus 10. And then we want to deal with these minus 4 and 6 points. Imagine f of x was equal to, say, x, and x was 6. Then a half of x, and I want it to be the same, I want it to be 12. So in other words, I want to double each of these numbers. So I get 12 and minus 8. And then my shape is just reflected underneath. So it goes down and up, and then it went, well, that was a turning point, and then we're down again. So we're done there. SQA Higher Maths 2025 Mock Paper 2 Question 10. Two variables x and y are connected by y equals ab to the x, and the graph of log 4 y against x is shown, and it gives us a couple of points, and we have to find the values of a and b. Now there's lots of ways and tricks you can do with this, but I just start from the basics for these ones. I don't want to have to memorize anything. So I've got y equals ab to the x, so I'll just write that down. And then I take the log of both sides, and the same base as what's in the question, log 4y. So I'll just say log 4 base y equals log 4 base ab to the x. The whole thing. Now I can separate that out using the rules of logs to separate something with a y x in it and something without. So I can say I've got log 4 base a plus log 4 base b to the x. Rules of logs say I can take the power down to the front, So we get log 4a plus x log 4b. And I'm always keeping in mind that this is a straight line. So the equation of a straight line in general is y equals mx plus c. So I kind of want to make it look like that, but except it's going to say log log. So I've got y, basically. This is my y, equals, well, I want something x, log base 4b, I'll just put that in brackets, times x, plus log base 4a. So now I've got it in the form of kind of y equals mx plus c. So that means that this bit here is my gradient and this bit here is my y-intercept. So let's see if I can find the gradient and y-intercept from the question. Well, first of all, it says 0, 3 is the y-intercept. So to work out c, since we've got 0, 3, that means that we've got log 4a just equals 3. Getting rid of that log then, 4 to the power of 3 equals a, and that means that a is 64, 4 cubed. Now we need to get our gradient. So looking at our gradient, we've got 2 points, 0, 3 and 8, 7. 0, 3 and 8, 7. So we can work out our gradient from that, 7 minus 3 over 8 minus 0. That's 4 over 8, which is 1/2. And we now know that log 4b is equal to that gradient because that's in front of x. So I can just say that log base 4 of b is equal to 1/2, and therefore 4 to the power of a half is equal to b. And the power of a half is the same as the square root, and therefore b is equal to 2. So we've answered the question. A is 64 and b is 2, or to put it another way, in terms of y equals ab to the x, it would look like 64 times 2 to the power of x. And we're done there. Higher Maths 2025 Mock Paper 2, question 11. Show the line with equation y equals 2x plus 7 as a tangent to the circle, well, there's the equation, and find the coordinates of the point of contact. So with questions like this, you want to make y or x a subject with your straight line part, which is already in y equals. If it isn't, you do that yourself, and then sub it into the circle. So y equals, so I've got x squared plus y squared is 2x plus 7 squared minus 10x plus 6, 2x plus 7 minus 46 equals 0. Expanding the brackets, so remember this is a square bracket, so if you're not sure, write it as double brackets just to be on the safe side. And the first one's just the last one's just a single bracket, so that's 12x, and then it's 42. Now I've still got 46. So double brackets, 2x times 2x is 4x squared, and then you'll have 14x and 14x. I'll just write it out longhand. And then you'll have 7 sevens is 49, minus 10x, plus 12x, plus 42, minus 46 equals 0. And then just make sure that you're collecting terms properly. So let's do the x squared first. I've got 5x squared. And then the x parts, I've got 14, 28, minus 10 is 18, plus 20 is 30. And then the number parts, I've got 49, then I've got plus 42 minus 46, which is minus 4, so 49 minus 4, which is 45. Quite often you get ones where you get a common factor at this point, in this case 5, to make a simple quadratic. 5x squared plus 6x plus 9. And to show that this is a tangent, you really want to be getting one solution or a repeated root. So hopefully that factorizes to a repeated root. Well, it does. You can do it as double brackets or a single bracket squared. X and x. 3 3s is 9, and plus 3 is 6, so that's 6x. And therefore x equals minus 3, and it's a repeated root. Therefore, we can just say y equals 2x plus 7 is a tangent. So we can just sub in x equals minus 3 to get our actual point of intersection. Y is equal to 2 times minus 3 plus 7. That's minus 6 plus 7. 7 minus 6 is 1. So our point of intersection is simply minus 3 and a 1. And we're done there. SQA Higher Maths 2025 Mock Paper 2, Question 12. We've got A, B, C, D, E, F, G, H as a prism. Okay, and it tells us a bunch of stuff about the vectors. We know that A to D is this. We know that D to C is this. We know that D to H is this. And we know that AD is 2 lots of BC. So we actually know what BC is because BC is a half of AD if you think about it. So C to H is equal to minus D to C, because we're going in the opposite direction, plus D to H. So that equals, be very careful, D to C is minus 10, so that becomes 10, minus 2, so that becomes 2, and minus 5 becomes 5, plus D to H is minus 3, 5, and 4. Notice I'm just writing it like this to make it easier to do the sums. That's just the numbers in front of I, J, and K. And I've already put a minus in the first one. 10 minus 3 is 7, 2 plus 5 is 7, and 5 plus 4 is 9. So putting it in IJK form, 7I, 7J, 9K, and we're done there. Part B, hence I find B to H in component form. Well, B to H is starting at here and ending here. So if I go up B to C, which we already know is a half AD, and then we do part A again, so we just add on part A. So it's nice and easy there. So B to C is a half A to D. A to D is 4 minus 4, 8. So for part B, we've got a half of 4 minus 4 and 8, plus the answer we just got, because it's the same root now from C. So that gives us a half of 4, and that's going to equal, just to be very clear, B to H. So that's 2 minus 2 and 4 plus 7, 7, 9. 2 plus 7 is 9, minus 2 plus 7 is 5, and 4 plus 9 is 13. So we get 9, 5, 13, and that is component form, so I'm done there. Part C, the point R lies in the line AB. Given that R to H is 2014, find R to B. Now, we don't know anything about A to B, but that's okay. So if I start at R, and I go all the way around back to H, because term is R to H, that takes me all the way up here. I mean, I want to get a route now back to B. So I need to go from H to B. So this is back along that way, down that way, and down that way. Now H to B, well, that's the same as the minus of B to H. So in other words, it's just R to B minus B to H. So if you can realise that, we're good to go. So for part C, R to B is equal to R to H minus B to H, because the opposite of H to B. Well, we know R to H. R to H is 2014. And part B gave us B to H, 9, 5, 13. So that means we can just do 2 minus 9 is minus 7, 0 minus 5 is minus 5, 14 minus 13 is 1. We've got minus 7, minus 5, 1. And it's in, doesn't tell you whether component form or not, so I'll just leave it in component form. And we're done there. SQA Higher Maths 2025 Mock Paper 2, Question 13. Looks like optimization, this one. A swimming pool is in the shape of a rectangle connected to a semicircle and has been designed to minimize the perimeter whilst maintaining the specific area covered by the surface of the pool. The rectangular part measures 4x meters by y meters. So 4x by y, right, that's fine. And the area of the surface of the pool is to be 32 square meters. Show that the perimeter is given by that. Right, let's have a look at this then. So the perimeter is going to be 4x plus a y plus a y. That's happy enough so far. Plus this semicircular part. So if I write that out, we've got y here and we've got y there. Semicircle is half of the circumference, and the circumference is pi times diameter. So this bit here is pi, and the diameter is 4x. I'll put a dot for times so it's clear. Pi times 4x, but then it's halved, so divide by 2. Well, that equals pi times 2x, or 2x pi. So we can write our perimeter for A to start with as 4x plus y plus 2x pi. Now, making that nice and neater, that's given me 4x plus 2x pi plus 2y. But their perimeter's not got any y in it, so we need to somehow get rid of that y. But it does say that the area, the surface area, is 32 square meters. So we can write an expression for the area of this thing. So if we're looking at area, we've got 4x times y for the rectangle, plus a half times pi times the radius squared. Now the radius is 4x divided by 2, which is 2x. So times 2x all squared. There's our area, and that equals 32. So you're always using a bit of information to eliminate the variable you don't want, in this case a y. So let's rearrange that. We get 4xy plus a half pi times 4x squared equals 32. So 4xy plus 2 pi x squared equals 32. So 4xy, because I want to make y the subject, equals 32 minus 2 pi x squared. So dividing by 4x, y equals 32 minus 2 pi x squared all over 4x. So now we can sub that y back into our perimeter. So that means that our perimeter is equal to 4x plus 2x pi. And then it says plus 2y plus 2 lots of this. And I'll try and simplify that in a minute. So that's a fraction. So that's 4x plus 2x pi. 2 cancels to give me 2 on the bottom. So that's plus 32 minus 2 pi x squared all over 2x. So I can divide by 2. Let's see if there's any fractions in our answer. There's a little bit x. But we can separate that out into 2 separate fractions. So we get 4x plus 2x pi. 32 divided by 2 is 16. So that gives you 16 over x for the first term. And 2 pi divided by 2 is just, well, pi. And x squared divided by x is just x. So this term here I'm looking at, 2's cancel and x cancels to just give minus x on the top. Minus pi x even, sorry. Or x pi. So that term goes with this term. So that gives me 4x plus pi x, because 2 pi x or 2x pi minus x pi is just x pi. I write it as pi x, so plus 16 over x. And let's just hope that that's what we're looking for. 4x plus pi x plus 16 over x. 4x plus pi x plus 16 over x, and we're done there. Now that was worth 3 marks. A lot of people struggle with that topic, and a lot of people then just turn off. If I were you, if you can't do part A, you're trying, and it's last minute, I would just do part B. At this stage, I would just do part B. I would not ignore the question, but I would do part B. Because part B of this question, because it's optimization, it mentions minimize or maximize, is always differentiation and stationary points. So I would just go from there, and they always give you the equation. So determine the minimum perimeter of a pool. So we just use our equation to minimize it. So this is P of x. So for part B, stationary points occur when P dash of x equals 0. So P dash of x is equal to, now don't we worry about the pi's here. Let's just get this ready to differentiate. 4x plus pi x, pi is just a number, plus 16, and then just take the x up to a minus 1. So 4x becomes 4. Pi x, so that's a power of 1. 1 times pi is pi. X to the 0 is gone. Then minus 16, x minus 2. And we're saying that equals 0 because we're looking for stationary points, for minimums and maximums. So let's just make that slightly neater. 4 plus pi minus 16 over x squared equals 0. So we need to somehow, quite often you get a x squared or cubed on the bottom, get rid of it, and the easiest way to do it is just times everything by x squared. So that implies we've got 4x squared plus pi x squared minus 16x squared over x squared equals 0, because 0 times x squared is x squared. But the x squared is now cancelled from here. So you end up with 4x squared plus pi x squared minus 16 equals 0. Quite a tricky one, this, because of that pi looking like problematic. But essentially, taking x squared as a common factor of this stuff, you've got 4 plus pi times x squared minus 16 equals 0. So it's kind of like a difference of two squares, but it's essentially something squared equals a number. So you can just take the 16 over. 4 plus pi x squared equals 16. So that means that x squared is 16 over 4 plus pi. Use a calculator for that. Square root 16 divided by 4 plus pi is equal to 1.496. But we have plus and minus answer, so that equals roughly 1.5 or minus 1.5. But is minus 1.5 valid? Probably not, because you can't have a negative length. So we just disregard it. I always write it down, but we'll just say we can't have that because you can't have no negative length. Or just write invalid. It's up to you. So we're going to use this. So that's the only turning point we need to consider. So we're going along to 1.5 and along. And we're looking at p dash of x. So you're usually just summing the numbers either side of 1.5 here. So I usually just pick 1 and 2 when they was closest numbers. And you can, I wouldn't write the answers to them down. I would just literally work it out in case you make a mistake. So p dash x is this. So putting 1 in, we get 4 plus pi minus 16 over 1 squared. That's a negative number. So I can write that's negative, 0, and then picking 2, 4 plus pi minus 16 over 2 2s is 4. That's a positive number. And therefore our shape, always work our shape out, down, along, up, and therefore x equals 1.5 as a minimum turning point. So x equals 1.5 minimizes the perimeter, and often you get told to stop there, but I would always check the question. Sometimes you need to sub it in to find the actual perimeter. Let's see what the question said. It said, find the minimum perimeter of the pool. So I'm going to have to sub it into the original perimeter equation that I've got, just as a final step. So there's the equation that we were given. So P of 1.5 we're putting in equals 4 1.5s plus pi 1.5 plus 16 over 1.5. Calculate a job for that. 4 times 1.5 plus pi times 1.5 plus 16 over 1.5 is about 21.4, whatever the units were. I don't know if the units were even in the question. Meters, because it said meters squared for area. 21.4 meters. And we're done there. This has been Mr Clem from Clem Maths. Today we did another mock paper 2 for SQA High Maths 2025. And obviously it is very, very close to the exams now. So if you need some last minute help, I'm doing my last minute live stream on Sunday the 11th of May at 6 p.m. for YouTube members only for Higher Maths. It's only £4.99. So join now, click the link to join to be a member and get that last minute boost to secure the best possible grades you can. Don't miss out. Take care, stay safe, and goodbye.